Alright, this is topic 4.5, tangents. Remember from a previous topic that a tangent is a line that hits the circle at one point. So that's the tangent line on this picture would be TX. And the symbol is an arrow, a line with two arrows. The point of tangency is the point on the circle, so that's point T. There's two interior points, P and I, and there's one exterior point, which is X. Exterior outside, interior is on the inside. Alright, here's a theorem for circles. If a line is tangent to a circle, then it's perpendicular to the radius drawn to the point of tangency. Look at this first picture. What that would mean would the point of tangency is B, the tangent line is AB, and the radius is BC. So that from that segment of the radius to the tangent, let's go ahead and draw in a 90-degree angle. Don't forget, perpendicular means it creates a right angle. Now if you'll notice, the triangle that's drawn has the legs 5 and 12, and the hypotenuse would be the length of CA. So let's use the Pythagorean Theorem to determine the length of CA. The legs are 5 and 12. When you add 5 squared, 25 plus 144, that's 169. If you square root 169, you'll get the length of your hypotenuse, which is 13. So that means that this length from C to A is 13. That's what we did our Pythagorean theorem for. So if 13 is the distance from all the way from C to A, this radius has to be 5, because all radii are congruent. That leaves 13 minus 5, which is 8, for your distance on the outside here. So your x is 8. One more theorem. If two segments form an exterior point, then they're tangent to the circle, then they're congruent. I'm going to go ahead and mark these segments congruent because this is a tangent line and so is this one, and this is the external point that goes to both Q and R. So on this one, we know these are congruent. So you'll have to take the expression 2x minus 3 and set that equal to 27 to solve for x. On this one, you'll add 3 to both sides. 2x would equal 30. So dividing the 2, both sides of the equation, x would be 15. If you wanted to check that, you could. If you want to check, let's go ahead and do a check. If you were to take 2x minus 3 and replace the 15, 2 times 15 is 30, 30 minus 3 is 27. So that would make a congruent tangent. Alright, let's move on to example 4. Here's a new vocabulary word, the word circumscribed. A circumscribed polygon is a polygon that it's inscribed inside, a circle that's inscribed inside a polygon. So if you notice, there's two tangent lines from LT to KT to this point. The external point W connects these two tangents, and the external point R connects these two tangents. So one thing by looking at this picture before we even start, we know that these are the same length, these are the same length, and these are the same length from the theorem on the other page. So that's going to help us solve this problem. They're telling us that the perimeter of the large triangle is 50, and they give us the length of TK. Let's label that. That's 3. And the length of WM is 9.5. And they want, our question here is to find the length of TR. So let's just label these X's. We can label this a 3 and this one a 9.5, these segments, because those tangents are congruent. So if you know the perimeter of any figure is just adding the lengths around. So I'm going to write it like this. We're going to take our unknown tangents, we're going to add our 3 tangents, and our 9.5. Those are all the segments that create the large perimeter. Now I'm going to go ahead and replace P with 50 because 50 is they gave that's the given. This is just 2x. If you add 3, 3, 9.5, and 9.5, that equals 25. Now you just solve for x. Subtract 25 on both sides. So 2x would equal 25. Divide out the 2. X would equal 12.5. Now 12.5 is not the answer because 12.5 is just the length of the two tangents. We're going to have to add the 3 to it because TR is the segment from goes through the L here. So you do need to add TR is the segment 3 with the 12.5, and that's going to be 15.5. Okay. Now we're going to use those theorems that we just talked about for example 5. On example 5, it's always a good idea to label the given information up here on the picture. So they told you that the length of OA is 12. I'm going to kind of write it right here in the middle. Just try to remember that's going to be 12. OB is 6, and there's an angle measurement here, BAC. BAC is 60. This angle right here, I'm going to put a little arrow, is 60 degrees. Okay. On this one, let's go back to that first theorem that you learned, that if a radius hits a tangent line at that point of tangency, it's a perpendicular, so it's 90 degrees. If 60 is this angle right here, this line right here is cutting it in half. Because these are equal, these triangles have the same, they're congruent to each other, so these angles have to both be 30 degrees. So there is a 30, 60, 90 triangle. So you can kind of tell because the hypotenuse is 12, the short leg is 6 on a 30, 60 triangle, 30, 60, 90. The long leg is always whatever your short leg is times the square root of 3. So I'm going to go ahead and label all that. This OC would be a radius, so that would be 6. Okay, I've labeled almost everything I can, so let's go look at the ones that we need to solve over here. Alright, OC is a radius, so that's 6. ED is a length of the diameter, so you have to double that. That's going to make that 12. AB is, where's AB? Okay, AB is this leg from this tangent line, and it's the long leg of the 30, 60, 90, so that's 6 times the square root of 3. AC is another long leg, so that's 6 times the square root of 3. BAO, remember that one was our 30-degree angle. OCA, let's see, where's that? OCA, that's our 90-degree angle. AOC is our 60-degree angle. EOC, where's the EOC? That's the same angle. Wait a minute. Yeah, this is interesting. Look how they did this. AOC is still naming the same angle that EOC is. It's just the shorter segment, but it's still the 60-degree angle. These really are the same angle. They're asking about the same angle. EA is the distance from here to here. Now this one we haven't labeled yet. If this radius is 6 and the entire length is 12, that means you would subtract, so EA would also be 6. Okay, I think that's it.